Good afternoon all. Today we have to learn about the concept of Rolle's theorem. So Rolle's theorem states that suppose that y equal to f of x is continuous at every point of the closed interval ab and differentiable at every point of interior open interval ab, and if f of a equal to f of b, the endpoints, then there is at least one number c between a and b or on the interval ab such that f dash c equal to 0. This is the statement of Rolle's theorem. So function is continuous at every point of the closed interval ab and is differentiable at every point in the open interval ab. And one more condition is that f of a, the endpoints, at the endpoints the function's value of the function are equal. Function is equal. F of a equal to f of b. Then there is a number c between a and b such that f dash c equal to 0. Now we have three problems. First problem is verify Rolle's theorem for the function f of x equal to x cube minus 9x. Our problem is verify for f of x equal to x cube minus 9x. Verify Rolle's theorem. We have to find, first we have to find where the interval closed interval ab. For that we have to find f of x equal to 0 points. So with this we can write f of x equal to x into x square minus 9. It implies x into x minus 3 into x plus 3. So f of x equal to 0 implies x equal to 0, 3 and minus 3. That is at the end points of the intervals minus 3 0 and 0 3 f of x equal to 0. Now consider f dash x. So we have f of x is x cube minus 9x. So f dash x is 3x square minus 9. So f dash x equal to 0 implies 3 into x square minus 9 equal to 0 or 3 into x square minus 3 equal to 0, which implies x square equal to 3 or x equal to plus or minus root 3. Out of this, minus root 3 element of the open interval minus 3 0 and root 3 element of 0 3. That is, we have intervals minus 3 0 and 0 3 in which f of x is differentiable and f of x is continuous and f dash x exists in minus 3 0, 0 3 also Also f of minus 3 equal to 0, f of 0 equal to 0 and f of 3 equal to 0, and there exists minus root 3 in interval minus 3 0 such that f dash of minus root 3 equal to 0, and there exists root 3 in interval 0 3 such that f dash of root 3 equal to 0. That is Rolle's theorem. Verified. We checked all conditions. It's the of Rolle's theorem. Now next problem is, suppose that f and g are differentiable on closed interval ab and f of a equal to g of a, and show that there is at least one point between a and b, that a is missing there, where the tangents of the graph of f and g are parallel. So given that f of a equal to g of a, and we have to show that there exists a point c such that f and g, graph of f and g are parallel. Now tangents of the graph of f and g are parallel. So for the starting we have to consider the function, a new function capital F, which is equal to f of x minus g of x. Consider the function capital F of x is equal to f of x minus g of x on closed interval ab. Since f and g are differentiable on closed interval ab, f minus g is differentiable, capital F is equal to f minus g is differentiable on AB. Also f of A is equal to f of B is equal to 0, since f of A is equal to f of A minus g of A, which is equal to 0, and f of B equal to f of B minus g of B. This is also equal to 0, given that this is f of x equal to g of x on closed interval AB. Thus, f satisfies all conditions of Rolle's theorem. Therefore, there is at least one point C lies between A and B such that f dash C equal to 0, which implies f dash C is f dash C minus g dash C equal to 0. Hence, there is at least one point C element of open interval AB such that f dash c equal to g dash c. We know that f dash c and g dash c are slopes of tangents at x equal to c to the graph of f of x and g of x respectively. It follows that there is at least one point between A and B where the tangent to the graph of f and g are parallel. Now the third problem. During a test drive of a prototype of a twin piloted submarine, the depth in feet of the submarine at time t in minutes is given by h of t equal to t cube into t minus 7 all raised to 4, where 0 less than or equal to t less than or equal to 7. Use Rolle's theorem to show that there is some instant of time t between 0 and 7 where h dash t equal to 0. Find the number c and interpret the result. We have a function h of t and a closed interval 0, 7. So this function is a polynomial, so it is continuous in that interval and we can differentiate that and it is differentiable in the open interval 0, 7. Now we have to check whether it is and we know that at t equal to 0 and 7 the function h of t equal to 0. So the conditions of Rolle's theorem is satisfied. So we can apply the Rolle's theorem so that there exists a point 0 and 7 when h dash t equal to 0. Now we have to find that number c and with the reference to the number c we can give the result. So given h of t equal to t cube into t minus 7 all raised to 4. H of t equal to 0 when implies t equal to 0 or t equal to 7. Since h of t is a polynomial, it is continuous everywhere. It is continuous everywhere. In particular, closed interval 0, 7. And differentiable in open interval 0, 7. Therefore, using Rolle's theorem, so given function f of x is differentiable continuous in open interval 0, 1, 0, 7 and differentiable in open interval 0, given function f of x is continuous in open interval in closed interval 0, 7 and differentiable in open interval 0, 7 and f of 0 equal to f of 7 equal to 0. Therefore, using Rolle's theorem, there exists a c element of open interval 0 7 such that f dash c equal to, not f, here it is h dash c equal to 0. Now consider h dash t, which is our h of t is t cube into t minus 7 all raised to 4. So this is product rule. H dash t equal to 0 implies h dash t is, we can use product rule. So t cube into 4 into t minus 7 all cube plus t minus 7 all raised to 4 into, in derivative of t cube is 3t square is equal to 0. So t square into t minus 7 all cube into 4t plus t minus 7 into 3 is equal to 0. That is t square into t minus 7 all cube into 40 plus 3t is 70 minus 3 into 7 is 21 equal to 0. That is t square into t minus 7 all cube into, we can take out 7, so this is t minus 3 equal to 0, which implies t equal to 0 7 3. And in this 0 3e element of closed interval 0 7 or open interval 0 7, that is c equal to 3 in open interval 0 7 therefore Rolle's theorem is verified. H of 0 is equal to 0, h of 7 is equal to 0 and h dash 3 equal to 0. Now we have to interpret the result using these values. That is, submarine is initially on the surface. That is h of 0 is equal to 0. H of 0 equal to 0 and h of 7 equal to 0. So return to the surface again. After 7 minutes. That is h of 7 is equal to 0. Now the vertical component of h dash 3 equal to 0, that the vertical component of velocity of submarine is 0 at t equal to 3, at which time the submarine attains the greatest depth. Of h3 is equal to 3 cube into t cube into t minus 7 all cube. So 3 minus 7 all raised to 4. So this is 3 cube into minus 4 raised to 4. 3 cube is 27 into 4 raised to 4 is equal to 256, which is equal to 256 into 27 is equal to 6912 feet.